Okay. So, next topic which we are studying is EMF of the cell and terminal potential. So, there is a small difference between these two. Both are potentials only. EMF is also potential of the cell. Terminal potential is also potential, but there is a small difference which we will discuss now. So, before that, first of all, we will study about internal resistance. Okay, ma? So, internal resistance of cell. See, ma, any cell will have some internal resistance also. Okay? So, what is meant by cell? This is a cell noma, and this is the external resistance which we are connecting. External resistance is R, and EMF of the cell is E. Okay? But practically, every cell will have some internal resistance also. What is meant by internal resistance? Resistance offered by the cell. In every cell, there will be some internal resistance. Because the charge, the current, it will enter into the battery noma, and that current also will get some opposition. So it means the battery also is opposing the flow of current. So that resistance offered by the cell is called as internal resistance. Okay. So therefore, instead of drawing the diagram like this, how I have to draw the diagram of a cell? Okay, ma? So this is the battery and this is small resistance. Okay. Plus minus, this is R and this is capital R. Okay. Now can you say what is meant by E, what is meant by R, and what is meant by capital R? E means what? Capacity of the cell, or you can call it as EMF of cell. Total capacitance, total capacity of the cell. Okay, ma? R means what? Resistance of what? Resistance of a cell. Previously, we studied only external resistances, no? Okay. Now we are adding one more resistance. That is internal resistance of cell also. Cell also will have some internal resistance. Because in the cell, many chemicals will be there, no? Electrolytes will be there, no? So these electrolytes also will oppose the flow of current. So therefore, cell also will have some resistance. So therefore, this total combination, I can call it as a battery. This total is called what? This total is called a cell, or group of cells, you can call it as a battery. So capacity of the cell plus its internal resistance. Both of them, it is called as cell. Are you able to understand? Okay, now see. And what is meant by capital R? Capital R is called as external resistance. External resistance. Okay, now see. So now can you say, what is the total resistance in the circuit, ma? What is the total resistance of the circuit, can you see? What is the total equivalent resistance of the circuit? Anybody? Total resistance is how much? See, this R and this small r, are they connected in series connection or parallel connection? Definitely series connection only, no? The current which enters here, it enters into this external resistance. Same current will enter into internal resistance also. So current is not dividing. If current is not dividing, it is what kind of connection? Series connection. So therefore I can say it is capital R plus small r. This is the total resistance of the cell. Okay. Now can you say how much current is produced in the circuit, ma? I value can be how much? Anybody? I is equals to V by R, no? According to Ohm's law, I is equal to V by R. This is the relation, no? V means what? Capacity of the battery. What is the total capacity of the battery? EMF. Divided by total resistance is how much? Capital R plus small r. Are you able to understand, ma? So this is the total current which is flowing in the circuit. So this much of current. So this I is equals to V by R. Are you able to understand? E is capacity of the battery, potential of the battery, and total resistance is R plus R. Okay. Now can you say, what is the potential drop inside battery? Can you say? Potential difference inside the battery will be how much? What is meant by potential difference inside the battery? Battery is giving this much EMF, no? And because of the internal resistance, it will consume its own energy, no? What resistance will do? Resistance will consume potential, no? Potential is nothing but work done per unit charge. Are you able to understand? So because of its internal resistance, the battery will consume its own energy. In this circuit, who is supplying energy? Battery. But battery also has some internal resistance, no? So because of this, battery will consume its own energy. తన ఎనర్జీలోంచి కొంచెం ఎనర్జీ తనే తినేస్తుంది అనమాట. ఆర్ ఏబుల్ టు అండర్స్టాండ్? ఇది ఎట్లంటే పాములు గుడ్లు పెట్టినట్టు అనమాట. సో స్నేక్స్ దే లే ఎగ్స్, అండ్ వెన్ దే ఆర్ వెరీ మచ్ హంగ్రీ దెన్ దే ఈట్ their own eggs. Are you able to understand, ma? Same concept. Energy is supplied by the battery, but because of its internal resistance, it will consume its own potential. Now, can you say what is the potential difference inside the battery? That is, what is the potential consumed by the battery? Can you say? Potential consumed by the battery is how much? Potential formula? I into R only, no? So, potential consumed by whom? Consumed by battery is equals to I into R. This is the formula, no? So I value is I only, and resistance of the battery is how much? Small r. Okay. So therefore, potential consumed by the battery is how much? I into R. I into small r. Okay. Where small r is the internal resistance of the battery. Arthamavutundi kada? And I value already we have calculated. No? What is I value? I value is equals to E divided by R plus R multiplied by R. Okay, so this will be the potential consumed by the battery. Are you able to understand, ma, how we are proceeding? First of all, we have calculated what is the total resistance of the circuit, what is the current produced by the circuit, then how much potential is consumed by the battery itself. Are you able to understand? Okay, now see. So after doing this much of calculation, completed, no, this side? Okay, now see. Okay, see, ma'am. So total capacity of battery is how much? Total capacity of battery is E, no, ma? Total capacity of the battery is E. Then potential consumed by battery is how much? Potential consumed by whom? Potential consumed by battery is how much? It is I into small r. Or you can write I value E by capital R plus small r multiplied by small r. Okay, ma? So therefore, potential left in the battery. Potential left in the battery is how much, can you say? Total capacity of the battery is E. Total potential difference that battery can supply is E. Out of this one, it is consuming its own potential, this much potential. Then what is the remaining potential inside the battery? E minus I into R. Clear, no, ma? So this is equals to E minus I into R. Are you able to understand what is happening? What is E? Total capacity of the battery. Out of its total potential, it is consuming some of its own potential. Then what is the remaining potential? E minus I into R. So this remaining potential, I can call it as terminal potential. Okay, ma? So therefore, what is the point I can write? This net potential supplied by battery is called terminal potential. Okay, ma? And this potential is applied to, and this potential, or I can say is consumed by, this potential is consumed by external resistors. Okay? So this remaining potential, who will consume this remaining potential, ma? External resistors are there, no? They will consume this remaining potential. Are you able to understand? Let us try to understand by taking one example. Clear? See, ma. See, consider this is a circuit, okay, and this is a cell, this is its internal resistance R, and this is the total cell. This is called as a cell. Are you able to understand me? So what is the total capacity of the battery? Total EMF of the battery is E. And it is supplying how much current? It is supplying I amount of current. So what is the potential difference inside this battery? It is I into small r. Remaining potential will be how much? If I consider here potential is 0 volts. Potential is always a reference value, no? Already we discussed, no? Without reference, you can never define potential. Are you able to understand? So for example, on the negative side, let us take potential is 0. Okay. Now can you say here potential will be how much? E? Baga alochin cheppandi. On the negative side, we are taking potential to be 0. Then what is the potential existing here? After crossing the battery, what will be the potential? After crossing the battery, what is the rise of potential? E is the rise of potential, no? But in this E value, I into R I have to remove, no? This is the total capacity supplied by the battery. But it is consuming its own potential. Then what is the remaining potential? Remaining potential is E minus I into R. And this is also called what? This is also called as terminal potential. Are you able to understand? Therefore, what is the total potential difference across a battery? Total potential difference across a battery after circuit is closed. After circuit is closed. This is equals to Vt minus 0. This is equal to Vt. That's all, no? When you close the circuit, current starts flowing, no? When current starts to flow, same current will flow through the battery also. Then battery will consume its own potential. Then what is the remaining potential? E minus IR. That potential I will call it as Vt, terminal potential. So therefore, what is the total potential difference across the battery? Here potential is how much? Vt. Here what is the potential? 0. So potential difference is how much across the battery? Vt minus 0. So Vt minus 0, Vt. Okay. So therefore, this potential I can call it as terminal potential. Why I can call it as terminal potential? Because on this side of the battery I have positive terminal, no? On the other side of the battery I have negative terminal. So potential difference existing at the battery is Vt, which is called as terminal potential. Potential difference existing between positive potential and negative potential of the battery. Eman artham avutunda? So Vt is called what? Terminal potential. Are you able to understand, ma? Concept is very simple. Battery will consume its own energy. Remaining energy is given to external resistors. That's it. Okay? Umesh వాళ్ళ నాయన ఉమేష్కి 100 రూపాయలు ఇచ్చినాడు. పోయి 4 పెరుగు ప్యాకెట్లు తీసుకొని రాపోరా అని ఇచ్చినాడు అనమాట. ఉమేష్ ఏం చేసినాడు? 20 రూపాయలు పెట్టి థమ్స్అప్ బాటిల్ కొనుక్కొని తాగేసినాడు అన్నమాట. ఇంకా రిమైనింగ్ అమౌంట్ ఎంత ఉంటుంది? 80. ఆ 80 రూపీస్తోనే ఆయన పెరుగు ప్యాకెట్లు తేవాలన్నమాట. అర్థమవుతుంది కదా? సో తన దగ్గర ఉన్న ఎనర్జీలో కొంచెము బ్యాటరీని ఉపయోగించేసుకుంటుంది. రిమైనింగ్ బ్యాటరీ మాత్రం ఎక్స్టర్నల్ రెసిస్టర్కి ఇస్తుంది. ఇస్ ఇట్ క్లియర్? ఓకే. నౌ లెట్ us do one small problem based on this one. Okay. So I will give a small question. Try to answer it. Sima. So this is an external resistor of resistance 10 ohms. This is a battery of EMF 10 volts and it is having an internal resistance of 1 ohm. Okay. So calculate first one, current produced in the circuit. Second question, potential drop inside battery. Okay, ma? Third question. So terminal potential. These three we are supposed to calculate. Fourth one, potential consumed by external resistor R. 4 questions. Come on. Try to calculate and say the answer. Let us do one thing. You take EMF to be 11 volts. Calculations will become easy. Okay. See, ma'am. Let us do this calculation. So, first of all, he is asking to find out total current. Total current, how can I calculate? Use Ohm's law. What is Ohm's law? I is equals to V by R. Total capacity of the battery is 11. Resistance is Sima. This one and this one, they are in series connection, no? The external resistor and internal resistance of the battery. Both of them, they are in series connection. So therefore, 10 plus 1 is how much? 11 by 11, 1 ampere of current. That's all, no? So current produced in the circuit is how much? Current produced in the circuit is 1 ampere of current. Second question. So potential difference inside the battery. Or instead of question like this, potential consumed by battery, that is better. Potential consumed by battery. Okay? Anybody? Chapandi. Battery will consume how much potential? Again same formula. V is equal to I into R. Again Ohm's law only. What is the current flowing in the battery? Same 1 ampere. Same 1 ampere will again enter into battery also, no? Clear number? So 1. And what is the resistance of the battery? Let us write it as small r. Resistance of the battery is also 1. So 1 volt. Okay? So total supply potential is 11. Out of 11, battery is consuming how much potential? 1 volt of potential. Third question. Terminal potential. Terminal potential. Terminal potential already we have written, no? E minus I into R. Correct, no? So 11 minus I into R already we have calculated 1. So 10 volts. Clear, no? So what is meant by 10 volts? Let us see. So this is the cell number. Here if potential is 0, here what is the potential? Here potential is 10 volts. Okay? Because 10 minus 0, 10. This is called terminal potential, no? That's it. Fourth question. Potential consumed by external resistor. This resistor will consume how much potential? With calculation, without calculation, say the answer. Potential consumed by external resistor. 10 only. Sima, battery is supplying how much potential? 11. Out of 11, it is consuming how much potential? 1. What is the remaining potential? 10. Who should consume that? External resistor, without calculation. With calculation, again same, V is equal to I into R. What is the current flowing in the battery, in the resistor? 1. Resistance is 10 volts. This is the potential consumed by external resistor. Understood, no? That's all very simple. Now see now. So, here we write a very important note point. A note point is that if circuit is open, if it is an open circuit, then potential difference and EMF, or just I say VT, terminal potential and EMF, both are equal. Okay? This is the statement which I am writing. If circuit is not closed, circuit is open circuit, then terminal potential and EMF, both of them, they are equal. Can you say what is the meaning of it? What does it mean? Anybody? Sima, consider this is an external resistor. This is a battery of EMF E. This is the internal resistance, small r. Okay, ma? And what I do is, I will open this circuit. Now, current cannot flow, no ma? Why current cannot flow? Because circuit is open. If circuit is open, whatever may be the battery capacity, current never flows. Are you able to understand? So this is open circuit. So what is the statement I am writing? If a circuit is open, terminal potential and EMF both will be equal. Can you say why? Why it is equal? Anybody? Previously, terminal potential EMF, they were not same, no? EMF was 11, but terminal potential is 10 only. But when you open the circuit, terminal potential and EMF, both of them, they will be equal. For example, if I take EMF is 10 volts, then terminal potential also will be 10 volts only. Okay? So here if potential is 0 volts, here potential will be 10 volts. 10 minus 0, 10. And EMF is also 10. Why? Why it is like that? Anybody? External resistance? External resistance consume అవ్వకపోతే నాకేం రా? When current is not flowing, what happens? అదే ఎలా? How can you say it? Okay. now current is not flowing. So what you want to say? చెప్పండి, ఆలోచించండి. కరెంటే లేదు అసలు అక్కడ. ఎనీబడి? వాట్ ఈస్ హ్యాపెనింగ్? See, when circuit is open, current is how much? Current flowing in the circuit will be zero. No current will flow. If current doesn't flow, current does not enter into internal resistance also. No. If current does not enter internal resistance, there is no drop of there is no drop of potential. If there is no drop of potential, why EMF will reduce? EMF will not reduce. అసలు ఇందులోకి కరెంటే వెళ్ళటం లేదు. కరెంటే వెళ్ళటం లేదు అంటే మీనింగ్ ఏమి? ఇక్కడ పొటెన్షియల్ డ్రాప్ జరగదు. If there is no potential drop, EMF and terminal potential, they will remain same. ఓకే. ఉమేష్ వాళ్ళ ఆయన ఉమేష్కి ప్రతిరోజు 100 రూపాయలు ఇచ్చి పెరుగు ప్యాకెట్లు తేయండి అన్నాడు అనమాట. మనోడు రోజు 20 రూపాయలు కొనుక్కొని తింటా ఉన్నాడు. అందుకు వాళ్ళ ఆయన ఏం చేసినాడు? ఆయనే పోయి తెచ్చుకున్నాడు అనమాట. ఇప్పుడు ఆ 20 రూపాయలు స్పెండ్ అవ్వదు కదా. సేమ్ కాన్సెప్ట్. Current is not at all entering into internal resistance. So there is no drop. If there is no drop, EMF and terminal potential, they will remain same. That is the concept. Clear now? So right now. దీనిపైన కూడా క్వశ్చన్స్ వస్తాయి మనకి. So therefore, what is the point we have to write? Okay. If circuit is open, current does not flow. Current does not flow. Okay. Therefore, no potential drop inside battery. Okay. We know that E is equals to E minus I into R, no ma? Okay. So Vt is equals to E minus 0 into R. So therefore Vt and E, both of them, they are equal. That is the point. Clear? Right. Okay ma? Now see. Now in the same concept of EMF and terminal potential, two conditions are very important. First condition, when battery is discharging. What is meant by discharging? Battery is supplying energy. Battery is supplying energy. So in our speakers we have mics, no ma? So appudu aa battery charge avutunda, discharge avutunda. Battery is supplying energy means it is discharging, no, it is losing its energy. Okay. So when battery is discharging, this is the conditions we have studied. Terminal potential is always less than EMF of the battery, because battery will consume its own potential. So remaining potential is called terminal potential. This is the circuit. Clear, no? When battery discharges, what happens? That is, when battery supplies energy, what happens? From positive side, current flows into the circuit, and again current re-enters into the battery. This is what happens, no? Now when battery has completely discharged, we can charge the batteries also, no? And this is the method of charging. How we charge batteries? We supply some what you call potential difference in our houses. Okay. Positive potential connected to positive, negative potential connected to negative. Now we are charging the battery. Charging the battery means what? We are giving energy into the battery. It means now current enters into the battery. See the direction of current. See here, the direction of current is in opposite direction. No? Here current is entering into the battery. It means we are raising the potential of the battery. In this condition, the supply potential must be greater than EMF, no ma? Okay. Are you able to understand the difference? In this condition, EMF is greater than terminal potential. But in this condition, you are charging the battery, no? So charging potential must be greater than EMF of the cell. So terminal potential is greater than EMF. So therefore, terminal potential is how much? EMF plus potential consumed by the battery. Are you able to understand the differences, ma? So therefore, what is I into R? Potential consumed by battery. Potential consumed by battery. Or cell. Cell is better. Okay, ma? So potential consumed by cell plus EMF of the cell, both should be equal to terminal potential. And now what is meant by terminal potential? Supply potential. The supply to which battery is connected. We have a supply of 220 volts, no, in our houses. That becomes the supply potential. So that should be greater than EMF of the cell when battery is charged. Are you able to understand about the conditions? This is when battery is discharging. This is the condition when battery is charging. Okay? That's it. Okay. Sima, see this next concept is grouping of cells. What is meant by grouping? Connecting the cells in series connection and parallel connection, or combination of series and parallel both. Okay. So this is a single cell, no? But a group of cells you can call it as battery. What is the difference between cell and battery, ma? Cell is a single unit. Cell is what? It is a single unit, ma. Battery, group of cells. Battery is called group of cells. Group of cells is called as a battery. Understood, ma? So three types of connections we will study: series connection, parallel connection, mixed connection. That is, in mixed connection you will have both series as well as parallel. Clear, no? Now see, first series connection. So EMF of the cells we are taking equal. Same EMF, E, E, E. Okay? Internal resistance are also same, R, R, R. And all of them, they are connected to external resistance, R. These are internal resistance of the cells. This is the external resistor. Now can you say, in this concept, total EMF will be how much? Total EMF will be sum of all the EMFs. Sum of all EMFs. Okay. So how many cells are connected, ma? N cells are connected, no? So N into E. Can I say this is the total EMF? If you are connected in series connection, we have to add all the EMFs, ma. And polarity is also same. Polarity means what? Positive, negative, positive, negative, positive, negative. Polarity is also same. If polarity is reversed, that is a different concept. But now up to here, all the cells have same polarity. So total EMF, you have to add all of them, N into E. Okay? Now can you say, what is the total internal or total resistance is how much? Total resistance is how much? Can you say, anybody? Total resistance of this circuit is how much? Chapandi. Very good. So total resistance will be N small r plus capital R. Can you say why? Why it is like that? N cells, they are connected in series, no? So N small r's, they are connected in series. So total resistance of internal resistances is N into R. And all of them, they are connected to external resistance, no? So to these resistors, this one is in series or parallel? Series only, no? So NR plus R. Because all of them, they are connected in series connection. Okay, ma? So therefore, can you say what is the total current produced in the circuit? V value? N into E. So N into E divided by NR plus capital R. So this is the current produced in the circuit when cells are connected in series connection. So very carefully you have to understand these conditions, ma, because directly questions can be given on this one. Okay. So total current produced is I is equals to NE divided by NR plus capital R. Okay. Now here we will write a very important case, ma. So listen to the case very carefully. Case is that, so if NR is much greater than capital R. This is first case. Okay, ma? What is NR? Total internal resistance of the cells. That's all. What is capital R? External resistance. So if internal resistance is much greater than internal resistance, then I can neglect capital R, no? For example, if you consider this is 100 ohms, this is only 1 ohm. I can neglect this 1 ohm, no? For example. So therefore, what happens? Case number 1. So I is equals to NE divided by NR. So N and N get cancelled. So it is E by R. So this is current due to single cell. Current due to what, ma? Current due to single cell. Current due to single cell I is equal to V by R only, no? Its resistance is EMF is C, resistance is R. So one single E divided by single R. Current due to single cell. Are you able to understand? Okay. Case number 2. Case number 2 is external resistance is much greater than N into R. Second case. Okay, ma? External resistance which we are connecting, this is very large when compared to sum of all the internal resistances. It means this is 100 ohms and this is 1 ohm. Let us consider. Okay. Then I can neglect this NR, no? Then what is the current flowing? I is equals to NE divided by capital R. That's all, no? So what is the meaning of this one? This is current due to N cells. Current due to N cells. No? This is I1, this is I2. Now can you say in which condition current flowing is maximum? Can you say? Case number 1 or case number 2? Huh? In case number 1, I got current only because of single cell, no small amount of current. But in case number 2, current due to how many cells I got? N cells, so definitely I2 is greater than I1, no? Clear, no ma? So therefore, to get maximum current, what is the condition? To get maximum current, what is the condition in series connection? External resistance should be much larger when compared to internal resistance. Then current flowing will be maximum. Is it clear? So these questions can be asked, ma. So understand very carefully. So therefore, what is the case? What is the note point we have understood by doing all this? Note point is that, okay, ma, in series connection, if external resistance is much larger, then current will be maximum. Okay, ma? So all the cells you are connecting in series connection and external resistance should be very large. Then you will get maximum amount of current from this battery. Understood, no? That's it. Now we will study about the second grouping, which is called parallel grouping of cells. Okay, ma? Parallel grouping. Parallel grouping means, I hope you know how to draw the diagram, no ma? So in advanced level you have many conditions. My EMFs are different, but up to Neet level I don't think they are necessary. Let us take all the EMFs to be equal. Okay? So this is one cell, internal resistance. Okay, ma? Second cell, its internal resistance. So like this, third cell, internal resistance. How many cells are connected? M cells in parallel. M cells are connected, and we are connecting all of them to some external resistance. Clear, no? So this is the external resistance R. EMFs are equal, E, 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 R, R, R. Okay? This is the condition. Now can you say in this condition, what is the total resistance of the circuit is how much? Anybody? All EMFs are equal, ma. All cells have same EMF and same internal resistance also, and all of them they are connected to external resistance capital R. Now can you say, okay, first of all we will calculate effective EMF. Effective EMF of circuit is how much? Effective EMF of circuit is E only. In series connection we have taken N into E, no? But here it is just equal to E only. Why? Because they are connected in parallel connection. Okay? Potential difference across this branch is E. Across this branch also E only. Across this branch also E only. Across external resistor also E only. Okay? So total EMF is how much? Only single E. But in series connection, N into E. Is it clear? Now, effective resistance is how much? Effective resistance of circuit is how much? Or R equivalent is how much? Can you say, anybody? M resistors are connected in parallel and there is one external resistor. So what is the total resistance of the circuit? అంతెందుకు రా, ఇంకొంచెం సింపుల్గా చెప్పండి. 1 by? No. Anybody? In this combination, what is the total resistance? Sima, M resistors, internal resistors, they are connected in parallel, no? If equal resistors are connected in parallel in M branches, so for all internal resistance will be R by M. This already I have discussed with you, no? Okay, see for example, this is 10 ohm resistor, another 10 ohm resistor, another 10 ohm resistor. So like this I am connecting 10 resistors. Okay. Now can you say what is the total resistance? 10 by 10 one only, no? Because they are connected in parallel, and how many branches are there? 10. So 10 by 10 is 1 ohms. Same concept here also. How many resistors are connected? M resistors. Resistance of each cell? R. So R by M. Now all these cells, they are connected in series with capital R, no? So plus capital R. That's it. That is how we write the resistors. Okay, ma? All these resistors, all these cells are this total combination. Is it in series or parallel? Series. Series. Because the current entering here, same current will enter into this external resistor also, no? So these total cells, they are in series with this cell. So that is why we are adding the resistors. R by M plus R. Is it clear? So therefore, if I take the LCM of it, R equivalent LCM if I take, then R plus M capital R divided by M. So therefore, what is the current flowing? I is equal to V by R. V is E. E divided by R equivalent is how much? R plus MR multiplied by M. Okay, ma? So this is the total current which is flowing in this circuit. By taking LCM, we got this calculation. Are you able to understand? Now here again we will write the cases. Cases. Just I will write one case, ma. So R is much greater than MR. One case is enough. No need of discussing two cases. One case is enough. Case 1. What is meant by R is greater than MR, ma? R means what? Internal resistance. Internal resistance is much greater than external resistance. M times of external resistance. It means internal resistance is very large. Okay. Then in this condition I can neglect MR, no? Because it is very small. So therefore I value will be how much? ME divided by R. So ME divided by R means what? M times current due to single cell. M times current due to single cell. So current has increased M times, no? So therefore for current to be maximum, what should happen in parallel connection? Which resistor should be greater? Internal resistance should be much larger, then you will get maximum current. But in series connection, external resistance should be much larger. That is the difference. Okay. So therefore, what is the note point here I have to write? Note point is that, okay, ma? In parallel connection, internal resistance of cells must be very large. Then maximum current flows. In the circuit. Understood, Nama? So these differences also will be asked in the examination. In series connection, external resistance should be very large. In parallel connection, internal resistance should be very large. Then maximum amount of current will flow. Okay? So that is about series and parallel. Okay, see, ma? So this is mixed grouping of cells, ma. It means you will find series cells also and parallel branches also. Okay? How many cells are connected in series? N cells. How many branches are there? M branches. And EMF of each cell is E. Okay, ma? And internal resistance is R. And all of them, they are connected to external resistance, capital R. Okay? Now can you say, what is the total resistance of this circuit? R equivalent is how much? Come on, man. So equivalent resistance will be how much? NE plus? Resistance only I am asking. Resistance is how much? Equivalent resistance of this circuit. See which resistors are in series, which are in parallel, then you see the calculation. How many cells are in series? N cells are in series, no? So series means you have to add the resistors, no? So therefore, N into R divided. That's all, no? So each branch has how much resistance, no? N into R. And how many branches are in parallel? M. So if equal resistors are connected in parallel, you have to divide by number of branches, no? NR by M. And all this combination, it is in series with capital R. So therefore, NR by M plus capital R. This is the total resistance of the circuit. Understood, Doma? So then what is the total EMF? Total EMF. What is the EMF of each branch? N into E. N into E. And how many branches are connected in parallel? So shall I divide? No need of dividing. All of them, they are in parallel, Noma. So total EMF is the EMF of single cell itself. So EMF is N into E only. You should not again divide by M. Okay. Therefore, what is the current flowing? I is equal to V by R, no? Potential is N into E divided by R value is how much? NR plus capital R divided by capital M. Okay, ma? So therefore, NE divided by NR plus MR multiplied by M. So this is the total current which is flowing in the circuit. If you take the LCMs, you will get this answer. Understood, Nama? This is the equation. Now there is one case in which maximum current flows. Shall I rub this? Okay. So note point we will write without any case. Note point is that current will be maximum, I will be I max when NR is equal to M capital R. This is the condition. Okay. So in the denominator I have NR, MR, no? When these two are equal, then current will be maximum. Okay. Or just you can say R is equals to NR divided by capital M. And what is NR divided by capital M? This is the total resistance of the cells, no? Total internal resistance. So NR by M is what? Total internal resistance. That's all, no? So when you look at the statement, what you understand, at which condition current will be maximum? When external resistance is equal to internal resistance, then current will be maximum. Clear? So therefore, what is the note point I have to write? Note point is that when external resistance E is equal to internal resistance, okay, ma? Then current will be maximum. Then current will be maximum. Okay. So these are the conditions which you should remember. Okay. So in series connection, which resistance should be bigger, ma? Series lo yedi peddaga undali cheppandi. External resistance should be bigger. Parallel, internal. Grouping, mixed grouping, equal. Internal resistance and external resistance, they should be equal. These three conditions you should remember. Okay. Very important concept. So see here, how many cells are connected in series? N cells. They are connected in series. And consider polarity of one cell is reversed. So 1, 2, 3. This cell's polarity is reversed and remaining cells are N. Total cells are N. Okay. Now in this condition, can you say, how can I calculate the total EMF of this connection? Polarity of one cell is reversed. Clear, no? Total number of cells are N. What is the effective EMF of this combination? Can you say? See, remaining cells are how many which are connected in same polarity? N minus 1 cells. No? So N minus 1 multiplied by E. This is the polarity of remaining cells. Remaining cells means what? Cells which are connected with same polarity. And one cell is connected in negative polarity, no? So you have to subtract that polarity. So minus E. Understood? N minus 1 into E is the number of cells which are connected in same polarity. This is the cell which is connected in opposite polarity. So therefore, if you do the calculation, so Ne minus E minus. That's all. So therefore, Ne minus 2E. So therefore, E is equals to N minus 2 into E. So this is the effective EMF. If how many cells are connected in polarity, opposite polarity, one cell is connected in opposite polarity. If two cells are connected, instead of 2 you have to write 4. 3 cells, 6. 4 cells, 8, like that. Understood, no? That's it. Okay. So therefore, general statement we will write. N cells in series, polarity of M cells is reversed. Then what is the effective EMF? It is N minus 2M multiplied by E. This is the statement. This is the general equation. Are you able to understand, ma? N cells are connected in series. Out of them, M cells polarity is reversed. M can be anything, 2, 3, 4, anything. Okay. Then here I got 2 number. 2 means 2 into 1 only, no? 2 means 2 into 1. It means polarity of one cell is reversed. Here how many cells polarity is reversed? M. So it is N minus 2M multiplied by E. That is the effective EMF. Understood, no? Very simple. See this question. So, there is a galvanometer connected with an unknown resistance in series is connected across two identical batteries, each of EMF 1.5. Let us draw the circuit. So, first of all, let us study about series connection. So, there are two cells which they have some internal resistance also, and each of them is 1.5 volts, 1.5 volts. Internal resistance he is asking us to find out, so R and R, and both of them they are connected to a galvanometer and an external resistance capital R. This is the first connection. Clear, no? What is a galvanometer? Just measured the strength of current. Small values of current is measured by galvanometer. Okay. And next what he is saying, when the batteries are connected in series, galvanometer records a current of, so here I value is 1 ampere. And when batteries are connected in parallel, it means I have to next draw parallel connection. Okay, ma? So in parallel connection, how can I draw? This is a cell, its internal resistance, cell, its internal resistance, and both of them they are connected to galvanometer and an external resistance of R. This is how I can connect now. So 1.5 volts, 1.5 volts, internal resistance is R and R. This is the connection. Series connection, parallel connection. Okay. Now in this, what is the amount of current flowing? Here current flowing is 0.6 amperes. Then R value he is asking us to find out. R value. Internal resistance he is asking us to find out. Okay. Now can you say, how can I calculate the total current which is flowing in this circuit? Anybody? I value is how much? I is equal to V by R, no? V is how much? R is how much? Come on. V is 2 into 1.5 because they are connected in series, no? Series means you have to add the capacity of the cells. So this is the total EMF. I is equal to V by R. R value, total resistance. These two, series, 2R. This one also in series, plus capital R. That's all. తమందు చేసింది అప్లై చేస్తున్నాం అంతే. What is the current flowing? 1 ampere is equal to 3 by 2R plus capital R. So if you simplify this one, then it is 2R plus capital R is equal to 3. Let it be my first equation. Two unknown quantities are there. R also I don't know, capital R also I don't know. It means I require one more equation. Second equation I can get from parallel connection. Now can you say here what is the value of current? Can you say? They are connected in parallel, no? So effective EMF is 1.5. 1.5 divided by total resistance. See, two resistors are in parallel, R by 2. That's all, no? R by 2. And this total combination is in series with capital R. So R by 2 plus capital R. Okay. Now here what is the strength of current? 0.6. So 0.6 is equals to 3 divided by R plus 2 into R. Okay, ma? So if I do this calculation, what I will get? 2R plus R is equal to 3 by 0.6, or 30 divided by 6. 30 divided by 6 is 5. This is my second equation. Okay. Have you understood, ma? So instead of complicating this one by multiplying with 0.6 all this, I have taken 0.6 to the other side. 30 by 6 is 5. This is my second equation. Already I got first equation. No? Just to solve first equation and second equation, you will get the required answers. Okay. So here we will do the calculation. First equation is 2R plus R is equal to 3. Second equation is 2 capital R plus R is equal to 5. I want to remove R, ma. So what I will do, I will multiply this total equation with minus 2. Okay. If I multiply this total equation with minus 2, what I will get? Minus 4R minus 2R is equal to minus 6. Let it be my third equation. So this is my second equation. So adding 2 and 3. Why I am adding? Because here I have 2R, here I have minus 2R. So therefore 2R plus R plus minus 4R minus 2R is equal to 5 minus 6. So 2R get cancelled. Minus 3R is equal to minus 1. So therefore R is equal to 1 by 3 ohms. That is my answer. Is it clear, ma? Techniques of solving the problem. That's it. Sima, let us try to understand this question on polarity of cells. See. So battery consisting of 10 cells in series has 2 cells reverse connected by mistake. So EMF of each cell is 1.5 and internal resistance is given, external is also given. So find the reduction in current due to 2 cells being reverse connected. Okay, ma? So if connection was good means what? If there is no reverse polarity, then what is the value of I? How many cells are connected in series, ma? 10. 10 into 1.5 divided by internal resistance is 0.1, no? How many cells are connected in series? 10 into 0.1, and there is one external resistor also which is connected in series, no? Which is 4. This is the amount of current. Are you able to understand? So how many cells in series? 10. EMF of each cell? 1.5. How many resistors are, how many internal resistors? 10. 10 into 0.1. External resistor is 4. Are you able to understand which formula we are using? NE divided by NR plus capital R when cells are connected in series connection. Okay. Now do the calculation. So 15 divided by 1 plus 4. 3 amperes of current. 3 amperes in which condition, ma? When polarity is good. There is no reverse polarity. Okay. Now if 2 cells are reverse polarity connected, no? 2 cells are connected in opposite polarity. Okay. In this condition, what is the equation we have written? Do you remember? I is equals to N minus 2M multiplied by E divided by NR plus capital R. Can I write like this? When M cells are connected in opposite polarity, this is the EMF. Do you remember? Chesnang already. N minus 2M multiplied by E divided by resistance is NR plus capital R. Okay. So how many cells are present totally? 10. And how many are connected in reverse polarity? 2. What is the EMF of each cell? 1.5 divided by 10 into 0.1 plus 4. Do this calculation. So 10 minus 4 is 6. 6 into 1.25? 9, 9. 9 divided by 14, 10 plus, 1 plus 4 is 5. So 9 by 5. Okay, ma? So this is the amount of current which will flow if cells they are connected in opposite polarity. If connection is good, this is the amount of current. If there is a wrong connection, this is the current. Therefore, what is the reduced current? Reduced current is what he is asking, no? Reduced current because of opposite polarity. Original current is 3A. Now the current when they are connected in opposite polarity is 9 by 5. Clear, no? So therefore, 15 minus 9 divided by 5. 15 minus 9 is 6. 6 by 5. 6 by 5 is 1.2 amperes of current. That is my answer. Clear, no? So this much amount of current will reduce if cells are connected in opposite polarity. Have you understood?